after you make a Taylor or Maclaurin polynomial, there are ways that you can use those polynomials depending on the way the function is written. In order to do this, the first thing you're going to have to do is to memorize these four. We could go through the whole process and show you where they come from, but I think after doing it several times like you've already done, these look familiar. And basically what's happened is we've found a pattern for each of them, and then there's a formula at the end for the pattern. And so you need to memorize that sine of x is x minus x to the third over 3 factorial plus x to the fifth over 5 factorial and so on. And the formula, in case you need it, is negative 1 to the n times x to the 2n plus 1 over 2n plus 1 factorial. Now, after you have those memorized, being able to use them is not that difficult. Some of the simplifying is kind of strange, but for the most part, it's pretty easy. You just have to think about what it is that you are looking for and what it is that you know. So the first one says that we want to find the power series for cosine of square root of 2x. And it says start with the power series for cosine of x and then replace x. So we're starting with cosine of x, and we're going to replace x. So 1 minus square root of 2x squared plus square root of 2x to the fourth. And then the pattern would continue. And then if I write the formula, I still just take the square root of 2x and plug it in the place of x. Now we do need to simplify this just a little bit to get it more in a reasonable form. The square root of 2x squared is 2x. So that's 2x over 2, so that's just an x. Alright, if square root of 2x squared is 2x, then square root of 2x to the fourth should be 2x times 2x. That's 4x to the fourth. And 4x to the fourth divided by 4 factorial, you can get rid of the fourths. So you get x to the fourth over 6 factorial. And then as far as the formula goes, the only thing that I can do is I could rewrite square root of 2x as 2x to the 1/2. Sorry, the square root shouldn't have been there. And then from there, I can rewrite the formula. I can multiply the 1/2 times the 2n to just get n. And the n's really never change. The only things that changes are these x's. Alright, find the power series for e to the x squared. So that means that I'm coming over here to e, and instead of x, I'm going to put x squareds in all their places. So I would have 1 plus x squared plus x squared squared would be x to the fourth. X squared to the third is going to be x to the sixth over 6. Then you want to write out the formula. So I'm plugging in an x squared, in for the 2n, or in for the x. And then the only thing that has to be simplified is this last part, and that's just x to the 2n over n factorial, because you multiply exponents. The next one says sine of x over 2. So I'm plugging in x over 2 in the x place. That's to the third over 3 factorial. And then we plug that into the formula for sine, so we have -1 to the n, x over 2 to the 2 plus 2n plus 1 over 2n plus 1 factorial. This one, the simplifying is kind of weird, but it's not hard. We've got x over 2 minus, alright, I know that'd be an x to the third, and then that's divided by 8, so the 8 goes on the bottom with the 3 factorial, so it's 8 times 6, so that's a 48 on the bottom. Next one would be x to the fifth. The bottom would be 32. And then times the 5 factorial. So it'd be 32 times 5 factorial, which is 120. So you get 3840. Dot, 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 or times. Leave your -1 to the n. That's x to the 2n plus 1 on the top. On the bottom, you can put your 2 to the 2n plus 1. And also your 2n plus 1. So both of those. That's really the only way to simplify that. You won't always have to do that, but if it were multiple choice, you might have to pick out which one would be the correct answer. So I'm going to leave some of these for you to do.
No.
I am going to do number 4 with you, because 4 is a little bit different. It says x cosine of x. That's different because you're not going to plug anything in for x. It means you're just going to multiply by cosine of x. So if you have the thing memorized, we know that we've got the x, and then the cosine of x is 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial, and then so on. -1 to the n, x to the 2n over 2n factorial. And then if I multiply, basically you're just going to distribute x times 1, x times x squared over 2, x times x to the fourth over 24, and then so on. And I'll get -1 to the n times, since I'm multiplying by another x, I'm adding exponents, so that's 2n plus 1 over 2n factorial. So 1, 2, 3, and 5 are all just plugging something in for x and seeing what you get. Number 6 is like number 4, except on number 6, you're going to divide by x on every one of them. Kind of like multiplying by 1 over x. So 1, 2, 3, and 5 are going to be your try problems. I'm going to go ahead and do number 7 with you. Alright, number 7a. Find the first four non-zero terms in the Taylor series expansion about x equals 0 for f of x equals square root of 1 plus x. For the sake of time and trying to make the video shorter, I'm not going to go through that process. I will tell you that you should get 1 plus 1/2 x, or x over 2, minus 1/8 x squared plus 1 over 16 x to the third. Sometimes you have to have the formula in at the end, and sometimes you don't. It really just depends. At this point, I'll be okay with not having it, but there may be some times where we need to come up with it. Alright, B says use the results in A to find the first non-zero terms in the series expansion about 0 for g of x equals this. Alright, go back and look at what f of x was. F of x was the square root of 1 plus x. G of x is the square root of 1 plus x to the third. So the thing that is different is the x to the third. Basically, an x to the third has been plugged in the place of x. So that's what I'm going to do here. 1 plus 1/2 x to the third minus 1/8. Alright, I'm going to plug an x to the third in there. So that would be x to the third squared. You multiply by exponents, so that would be x to the sixth. plus 1 over 16. All right, that'd be x to the third, multiply so you get to the 9th, and then the pattern will continue. C. Find the first 4 non-zero terms in the Taylor series expansion about x equals 0 for a function such that the derivative equals that and h of 0 equals 4. Now, what you need to know about these series is that if I want to find the derivative, I can just say, find the derivative of g. If I found the derivative of g, I would just find the derivative of each of those terms, and it would be 0 plus 3/2 x squared minus 3/4 x to the 5th, and so on. Well, what they want is they want g of x to be the derivative. So what we're going to have to do is we're going to have to find h of x, which means we were going to do the integral of g of x, because we want to go backwards. We want the derivative to be g. Okay, so we need to find the antiderivative. All right, so the antiderivative, just do each piece. The antiderivative of 1 is x. The antiderivative of 1/2 x to the third, I'm adding 1 and dividing by it, so it would be 1/8 x to the 8, or x to the 4th. The next one, okay, add 1 is to the 7th, divide by it, so it would be 1 over 56 x to the 7th. Add 1 to the 9th, so it would be x to the 10th, so it would be 1 over 160 x to the 10th. Now, because they said that they want h of 0 to be 4, I know when you take the antiderivative of something, you always have a plus c on the end. So what we have to do is we have to plug a 0 in for all the x's and set it equal to 4. So we'd have 0 plus 0 minus 0 plus 0 plus c equals 4. So that means c is 4. And if I rewrite the equation, you would get x plus 1/8 x to the 4th minus 1 over 56 x to the 7th plus 1 over 160 x to the 10th plus 4.